When viewed from space, astronauts can see that the Earth has a delicate blue rim. Our atmosphere appears as a thin band of light. It is the gaseous envelope that surrounds our planet, making all life possible and protecting it. Although the atmosphere extends several thousand kilometers high, the essential layer, the biosphere, is surprisingly small compared to the Earth. Yet this transparent layer determines our weather and climate on this planet. Imagine you're standing at the bottom of an ocean and looking up. Above you are masses of water kilometers high. That is exactly how we live, not underwater, but beneath an ocean of air. The atmosphere is a gigantic ocean of nitrogen, oxygen, and trace gases. With their weight, these gases press down on the Earth's surface and create atmospheric pressure. At sea level, this pressure is 1,013 hectopascals. That corresponds roughly to the weight of 10 tons of air on every square meter of the Earth's surface. A tremendous force. Why does this enormous amount of gas stay with us at all? The answer lies in the Earth's enormous mass. The Earth's gravity attracts the gases and holds them in place. This attraction has another consequence. The air is compressed toward the Earth's surface. It is very dense at the bottom and becomes thinner and thinner as it rises. Anyone who has ever been to the mountains knows this feeling. With every meter of altitude, it gets cooler and breathing becomes more difficult. At an altitude of approximately 5,400 meters, half of the atmosphere's mass lies below us. The temperature at this altitude is about 255 Kelvin, corresponding to the Earth's effective radiating temperature. The air pressure has halved, and the temperature has dropped by at least 35 degrees. The atmosphere follows the same physical laws as any other gas. When air is compressed, it heats up, it gets warmer as you go down. When it expands, it cools, it gets cooler higher up. That is why the temperature in the lower atmosphere decreases with increasing altitude. A greenhouse effect is not necessary for this, simple physics is sufficient. These simple physical principles determine the structure of our atmosphere. And they are the driving force behind one of our planet's most complex systems, the weather. The Earth is not heated equally by the sun everywhere. Polar regions receive significantly less energy. Tropical regions are very large and receive a lot of energy. These temperature differences create pressure differences. And pressure differences set the air in motion. This is how winds are formed. Together with water vapor, clouds, rain, and storms form. Abundant thermal energy and water availability also lead to high rates of evaporation. This results in tropical rainforests. At the same time, the water vapor in the air stabilizes the climate. This process involves the storage and transport of latent heat. The atmosphere becomes a giant global machine, distributing heat, water, and energy around the planet. Viewed from space, the atmosphere looks like a wafer-thin veil. A fragile layer, barely thicker than the skin of an apple relative to the size of our planet. And yet it contains everything we need to live. The air we breathe, the water that falls as rain, and the complex system of heat, forces, and movements we call weather. So the next time you look up at the sky, remember, you are not looking into emptiness, but into the vast expanse of space. You are standing neither in a greenhouse nor under a bell jar. You are looking into the Earth's greatest ocean. The ocean of air. Our atmosphere. Take care and never stop exploring the world around you. Thank you for listening and enjoy the wonder of our atmosphere.